to Chapter 4. Our first lesson in Chapter 4 has to do with prime factorization. Sounds all big and fancy, but really it's just breaking down big numbers or composite numbers into small prime numbers. Now let's talk about it a little bit more. So what is a prime number? I know you guys have probably talked about this before, but a prime number is a number where the factors are only one in itself. So basically the only two numbers that can multiply together to give you that number is 1 in itself. Like 7 is an example of a prime number. So 7, the only things that can multiply to get 7 is 1 times 7. Because nothing else multiplies together to get you 7. A composite number is almost on the other side of the spectrum. You have numbers that have more than 2 factors. So it's numbers like 12 that can be broken down into 3 and 4. It can be broken down into 2 and 6. So it's more than just 1 and 12. Now we're talking about breaking it down to factors. So what is a factor? A factor or factors are numbers that you can multiply together to get another number. So 3 and 2 are examples of 6 because they're multiplied together to give you 6. Alright, so now we have some little rules. I know this is kind of small and sloppy, but try to listen to me. We'll be repeating it tons in class. So there are certain little rules that will tell you if it's prime or composite pretty quickly. Now they don't always work, but they do most of the time. So if you want to know if a 2 goes into a number, so if 2 times something gives you that number, look at the last digit of the number. So look in the ones place. If there's an even number there, then it's divisible by 2. So numbers like 12 because 2's in the ones place. Numbers like 24 because a 4 is in the ones place. So if it ends at an even number, 2 will go into it. If the digits add up to give you a number that 3 goes into, then that means 3 goes into that big number. So for example, if you wanted to do 12. So does 3 go into 12? You would add the 1 in the tens place and add the 2 in the ones place of the 12. So 1 plus 2, and that will give you 3. So obviously 3 goes into 3. So that means that 3 goes into 12, and we'll remember that 3 times 4 gives you 12. Okay, if you want to know if 5 goes into a number, look at the last digit. Does it end in a 5 or a 0? So any numbers like, 10, because 10 ends in a 0, so 5 goes into 10. 25, 5 goes into 25 because it ends in a 5. Now, in order to know if 10 goes into a number, it has to end in a 0. So 10, 20, 30, 40, 100, all of those numbers 10 goes into because it ends in a 0. Alright, so now what are we going to be doing with these prime numbers and these composite numbers? So we are going to be factoring them. So prime factorization sounds all fancy, but it basically means breaking down a composite number, so a number that has more than one factor, into prime factors using the factor tree method. So these numbers, basically we're getting this big number, we're breaking it down, it kind of looks like a tree. You're breaking it down into smaller, more complex roots. So you're breaking it down. So you're breaking it down into only prime numbers. So, for example, I have 24. 6 times 4 gives me 24. But we can't stop there because both 6 and 4 have more than 2 factors. So, 2 times 3 gives you 6. So it'll be 2 times 3 times 2 times 2 because 2 times 2 gives you 4. So basically, this big number can be broken down into a product of these small numbers. So if you multiply them all together, you're going to get this big number. So we are going to be using this for several lessons after this. So this is a very basic skill that we need to master before we move on. So you'll be able to see in a few other lessons of how it's actually going to be used. But now we got to master it. So let's go ahead and do some practice. Alright, let's look at example number 1. So these first 3 examples we're going to be writing. Is this number prime or composite? So is it only 1 in that number multiplied together to give you that number? Or is it other numbers? Can it break down to more factors? Let's see. So 11, let's first try to use our rules. Let's look at this last number. Does it end in an even number? No. So that means 2 does not go into this number. Does it end in a 0? No. So that means that 10 and 5 do not go into this number. Does it end in a 5? No, so that means 5 does not go into this number. And if we add 1 plus 1, that gives us 2. 3 doesn't go into 2. So that means that this number is prime. And even if you think of your number facts, do you ever get a number that multiplies to give you 11? No. Okay, number 2. We have 15. So let's go ahead and look at our little rules. So it ends in a 5. So that means that 5 goes into this number. So, and if we can remember, 3 times 5 gives you 15. So that's like, okay, well, some numbers, obviously it has more factors other than 1 in itself because it has 3 and 5. So we know that this number is composite. All right, let's go ahead and look at this number, 24. All right, so the last digit is a 4. And that's an even number, so that means that 2 goes into this number. And if we remember our number facts, our multiplication facts, we know that 2 times 12 is going to give us 24. So we obviously know it has more factors than 1 in itself. So this one is composite as well. Alright, so now what do we do with these composite numbers? We need to break them down into a product of primes. So, sounds all fancy, but product means multiplication. So you're multiplying small prime numbers together to give you a final answer, which is this big composite number. So we are going to go ahead and break it down. So we're going to use a factor tree. So this is sometimes kind of fun, but you have to make it neat because you're going to get lost and you're going to forget some numbers in your prime factorization. So once you start doing all these little tree things, you can get all out of order and all kinds of stuff. So we got to be neat. That's the most important thing. So let's go ahead and break down 18. I know that 2 times 9 is going to give me 18. Now, one thing that I'm going to do here, I'm going to go ahead and circle my 2 because 2 is prime, so I do not have to break that down anymore. But 9, we have more than 2 factors. We have 3 and 3. So I'm going to break that down as well. So I'm going to break down my 9 into 3 times 3. So I'm going to circle the 3's because they are both prime. So now I know that my prime factorization, so when they say, what is a prime factorization? Don't stop here. This is the first step. This is to find the prime factorization. So the prime factorization is 2 times 3 times 3. Or you can write it as 2 times 3 squared. Since we're multiplying 3 times, or 3 2 times, we'll do it 3 to the second power. Now this really comes in handy if you have 3 times 3 times 3 times 3 times 3 or anything like that that goes on for a while. You might want to raise it to a power just so you don't have to write them all down again. So there you go. That's the prime factorization of 18. Now let's go ahead and break down 28. So what times what gives us 28? So I know that 7 times 4 is going to give me 28. So 7 is prime. I know no other number goes into 7, so I'm going to circle it so I don't forget about it. Because up here, you might have forgotten about this too and just wrote 3 times 3. But that gives you 9, so it's not 18. So you have to write down every single prime number. So we have 7. Now we're going to go ahead and break 4 down into 2 times 2. So I'm going to circle the 2's because they're prime. So now it's time to write my prime factorization. It's 7 times 2 times 2. Or you can write it as 7 times 2 squared. So raised to the second power because we're multiplying it 2 times. Alright, now we have to go ahead and break down this monomial. This number that has numbers and variables multiplied together. So how do we break down something like this? So basically what we're going to do is break down term by term, okay? And then we're going to put it all together because all of this is multiplied together anyway. So we're going to multiply it all together as a product of primes. So we already broke down 18, but let's show it again. When we break down 18, we have 2 times 9, circle the 2 because it's prime, and then 3 times 3. Now that is prime. Now that only gives us 18. We still need x and y. So we'll break down the x, and that's only x multiplied 1 time. And then we have the y, and that's only multiplied 1 time. So our prime factorization is going to be 2 times 3 times 3 times x times y. Or you can write it as 2 times 3 squared times x times y. So either or would be fine. Now this is how you're breaking down composite numbers into a product of primes, which is called prime factorization. If this lesson confused you a little bit, feel free to rewind it, watch it again. Watch just parts of it that you need to watch again, anything to help you. If you have more questions, go ahead and go in your book. There's some more examples. And then for sure bring them in tomorrow and we will have a discussion. Alright, let's look at your on your own questions. Alright, you have 5 problems to do for me. For the first 2 problems, you're going to go ahead and write if the number is prime or composite. Remember to use our rules to see if 2, 5, 3, or 10 go into the number. Alright, for the last 3, you're going to find the prime factorization. So you're going to use the factor tree and then write the number as a product of prime numbers. So you're going to be writing it as multiplying all small prime numbers together. Alright, good luck. We'll see what you get tomorrow.